Hello, Class 12th Physics, Ray Optics for JEE, NEET and boards. Here are some questions, but before that, let's take a look on some of the formulae. Refractive index of a medium equal to C upon V, equal to wavelength of light in vacuum to wavelength of light in that medium, sin I upon sin R, 1 upon sin IC, that is critical angle, that is equal to real depth upon apparent depth. In the same way, for a curved surface separating two media and refraction taking place from rarer to denser, where eta 1 is the refractive index of rarer medium, eta 2 denser medium, then it is eta 2 by V minus eta 1 by U equal to eta 2 minus eta 1 upon R. And Lensmaker's formula, 1 upon F equal to 1 upon R1 minus 1 upon R2 multiplied by eta 2 1, that is of material of that lens with respect to medium in which it is placed, minus 1, which is further equal to 1 upon V minus 1 upon U, and which is equal to P, power of lens. Also magnification, so linear magnification is Hi upon Ho, which is V upon U, and aerial magnification is area of image upon area of object, which is equal to V square upon U square. Now let's take a look on this question. Okay, so here it is. The following diagram could be correct if is missing there, if and there are some condition. Okay, so first thing, we know that this is a converging lens. Generally we call it convex lens, we call it converging lens, but we forget that its shape doesn't determine whether it is converging or diverging. So I can directly tell you that if this medium has more optical density, greater refractive index, then it will converge, and if this medium has lesser refractive index, then it will diverge. So directly we can give its answer. Okay, but let's understand it deeply. So I'm drawing a convex lens. This surface, its center is here, C1, and this surface, its center is here, C2. Okay, this ray parallel to the principal axis. Now we will draw normal to its surface. It will bend toward the normal. It has to converge somewhere here, and after passing through this surface, it is going denser to rarer, it will move away from the normal, then it falls somewhere here. Now if this thing is happening if this is denser, but now if this is denser, then okay, this time it will bend away from the normal somewhere here. It appears that it is coming from here, and now it is again going to denser medium, rarer to denser. So it has to go this way, but it will bend toward the normal. So now it will appears to get diverged from here. So that is why it means if this medium is denser, then it will, despite it is convex, it will diverge. So it is diverging. It must be, eta 2 must be a denser medium. Okay, so this is not possible. What about this? Eta 1 equal to eta 2. Well, we don't have any direct evidence for that. Two options are there. Let's check this one also. Eta 1 is less than eta g, means it is denser. It means eta 2 is also less than eta g, which is not there, because this must be a denser medium. Eta 1 greater than eta g, it means eta 2 is also greater than eta g, which is possible. So this can be a possibility under no circumstances. No, actually, if here also they would give us any condition, like here eta 1 equal to eta g, then there would be no condition, then this answer would be the correct answer. But this is most appropriate answer. Why? Because eta 1, actually we don't have any evidence for eta 1, but if eta 1 and eta 2 are equal, and eta 1 is greater than eta g, means eta 2 is greater than eta g, both are equal. So it means eta 2 is denser medium. So remember that thing. If this medium is denser than the material by which lens is made, then it will diverge, although it is a convex lens. This one is interesting one. A double convex lens is cut in such a way it gives two plano-convex lenses. Each of focal length f. Find focal length of double convex lens before it was cut. Both radii of curvature are equal. So earlier the lens was this, and later it was cut into two parts, and now this plano-convex has focal length f. Both surfaces have equal radii of curvature, so what we can do here, 1 upon f equal to refractive index minus 1, actually g with respect to a, but okay, nothing is given, so it means it is placed in air. Okay, 1 upon r1, let us suppose that is r, and minus 1 upon this plane surface, infinite. Some people might say that I have to put negative also because r2 is negative. Okay, it doesn't matter. Okay, so this 1 upon f is equal to eta minus 1 and 1 by r. Now what about this? So 1 upon f equal to eta minus 1, 1 upon r minus 1 upon minus r. So it will be 2 by r. So we can write 1 upon f, 1 upon f for double convex lens. 1 upon capital F, I have used capital F for focal length of this lens, is equal to this entire multiplied by 2. And this entire is 1 upon f multiplied by 2. That is 2 by f. So f is f by 2. Okay, this one, a concave lens of glass of refractive index 1. Oh, sorry. I don't know, some throat infection. Of refractive index 1.5 has both surfaces of same radius of curvature r. On immersion in a medium of refractive index 1.7, find focal length and nature of. So remember this thing. Refractive index of glass with respect to air is given 1.5. And refractive index of that medium with respect to air is given as 1.7. Remember this thing, we will not put this in the formula of Lensmaker formula. No, actually we have to put in this formula, in this Lensmaker formula. Don't remember it in this form. Always glass with respect to some medium. Glass with respect to air, glass with respect to water, whatever it is, with respect to some medium. So here we have to find refractive index of glass with respect to that medium. So refractive index of glass with respect to air upon refractive index of medium with respect to air, which is 1.5 by 1.7. So it is 15 by 17. And that's it. 1 upon f equal to this 15 by 17 minus 1. It is concave. For concave, r1 is negative and r2 is positive. If we solve this, it will be minus 2 by 17. And here, multiplied by minus 2 by r. It is f equal to 17r by 4. And that's all. With positive sign, of course. So its nature will be converging. Alright, so in this question, a point object is placed at a distance 20 centimeter from thin lens, plane of convex lens of focal length 15 centimeter. If plane surface is silvered, then find image distance. So this question is a combination of refraction and reflection. Let's draw it first so that we can visualize this. Here it is. Okay, so this is a plane of convex lens, and I have silvered this surface, and here its center of curvature. Object is placed somewhere here, so we'll put normal to that incident ray. It will bend toward the normal, strike this silvered surface, will get reflected. It had to go this way, but reflected ray, it's difficult to show reflected ray here. Let me draw another one, much clearer, so that we can visualize it easily. See, actually it is not that important, but in order to understand what is going in this question, it is required to draw it clearly. So here it is. Now, okay, so this is the incident ray for that plane surface, that mirror, and there will be reflection takes place, but it again undergoes a refraction through that lens. So we can divide this question, instead of refraction and reflection, we can divide this question into two parts, 2 times refraction through the lens. So for first surface, 1 upon f equal to 1 upon v minus 1 upon u, and here it is. So it is quite simple that ordinarily as we solve these problems, not a big issue with this. So here, all right, so this is v equal to 60 centimeters. So this, there it is, 60 centimeter. Now see, this image will act as object, and it will again, we can assume that it is going back and undergo refraction through the lens. And okay, this time incident ray is from left to right as usual, and this point act as object. I mean, this 60 centimeter away the point is, the image formed acts as object, but it is in the direction of incident ray. That's pretty surprising. Actually, it is not happening. No ray is going from this 60 centimeter away point, but we can assume something like this. So in actual practice, it is not happening. This 60 centimeter distance is along the direction of incident ray. Remember, we generally call that object distance is always negative, but no. Recall that sign convention thing. If it is in the direction of incident ray, then distance will be taken as positive. So this 60 will be taken as positive. Remember, it is along the direction of incident light. That is why. So now it's so simple. So remember this thing you have to keep in your mind, that distances measured in the direction of incident ray have to be taken as positive. So that was the key point of this question. So this question had many folds, and just understand those things. Okay, so here it is, 12 centimeter is the answer. And all right, so it was a nice question. So last question. Okay, so if you have done those experiments in practical manual, I hope you have seen this. So we draw this diagram between u and v, and then there are some value given. We draw a 45-degree angle here, and then we spot these values, and the focal length is half of these values. I mean, one of the values. So that will be 5. But okay, we can do this thing also. All right, so we can do this, and I hope it is an easy calculation for you people. But remember, in this question it was given that 10 on both sides, but they can give single value there, and they can give that 45-degree angle. Then we can understand that the other value will also be same.